So try this again. 73. Let's save that to the end if we get through all the questions, because that's not going to be a quiz-worthy question. It's only up to 66 I put on the quiz, okay? So 7 to 66 on the quiz. But we can do 73 once we do all the other ones. Peyton, go ahead. 18, all right. Josh?
64.
64, okay. Anybody else? Just look through your book. If you have your book. 73, right up there. But we're going to save this for last because it's not going to be on the quiz. Peyton, got another one? 42. All right. And you can pick an odd one, too. You don't have to pick the even ones, but... Haley, do you have one? 34. Okay. All right, let's just do these. Okay, somebody write those down. Did you anybody write those down for me? Did you write them down? Okay, because I'll be scrolling down the bottom of this and I don't have to go up to the top every single time. Okay, you got it? Okay, so 18 is the first one, so let's do that. All righty. Oh my, you picked a crazy one, didn't you? Cube root 3xy squared over 81 x to the fourth y squared. Okay. That root actually goes all the way to here. Sorry, I messed it up a little bit. So all this fraction's under the cube root. All right, well, let's see. What do you think we can do before we even think about the cube root? Just look at the fraction inside of there. What do you think you can do with that? Yeah, let's simplify that first of all before we do anything else, okay? Don't even think about taking the cube root until everything inside of there is simplified. So let's do that. Let's do this in different colors so it stands out. Forget the 3 and the 81 for right now. Let's do the x and the x to the fourth. So I got an x on top and x to the fourth on the bottom. How does that simplify? That x cancels out with what? One of these. So what do we have left on the bottom? X to the third. Okay. What about the y squareds? Yeah, they just completely cancel out. Exactly. Okay. Now let's go to the 3 and the 81. Does 3 divide into 81? Do you know the little trick to figure out if 3 divides into a number? Anybody teach you that? So 81, it's not one of the numbers that I think of, you know, in the multiplication tables, but 8 plus 1 is what? 9. Does 3 go into 9? Yeah. Nobody's taught you that trick before? Okay, yeah. Some of you not. But if you just take the digits and add them up, if 3 divides into that number, when you add up the digits, then 3 goes into 81, right? Now we got to figure out how many times does 3 go into 81. I think it's 27, isn't it? You can just do that on your own. Okay, so that goes 27 times. So it looks like a mess. Let's clean it up a little bit. So it's the cube root of, what's left on top now? The y squared canceled out. This x canceled out. This turned into a 1, so we have a 1 on the top. Then on the bottom, we have what? A 27. And what else? The y squared cancel out. What's that other thing? X to the third. Good. Okay? So that's the first thing I would do on a problem like this. All right, before you start cube root and stuff. Now, like I've said many times before, they rig these problems. Okay, the author of this book rigged this so it canceled out so that I can take the cube root of everything in here. Do you see that? So now it works out pretty easy for us. In real life, that hardly ever happens. But in math books, especially high school math books, that happens a lot. So what I'm going to do, you got a fraction, so what you can do is you can take the cube root of the top. Might even be able to just do that in your head, tell you the truth. But I'm showing you all the steps, okay? And then you take the cube root of the bottom. So it's the cube root of 27x cubed. Now, we should be able to just get our answer right now, shouldn't we? What's the cube root of 1? It's 1. All right, any root of 1 is 1, okay? So there's a 1 on the top. Let's do this. We're taking the cube root of 27 and we're taking the cube root of x cubed. What's the cube root of 27? That's something that should just pop in your head. Cube root of 27 is 3, right? And now we also got to take the cube root of x cubed. That's just an x. That's your answer. We can't fact check because there's no, these answers aren't in the back of the book, and I don't have the answer key. But I'm pretty sure that's right. So that wasn't as hard as it looked at the beginning, was it? Okay, as long as you just simplify the stuff inside of there first, and then you can just take the cube root of the top, the bottom, figure it out, you're good to go. All right, what was the next one? 34. So we'll go in numerical order. With this new projector, I can use colors now, can't I? Can you see it okay? If I use the colors? That other projector didn't work so good, but this one is pretty nice. All right, so 34. So it's 9 times the cube root of 24 minus the cube root of 81. All righty. Remember, this is a cube root. It's not 9 times 3. Everybody got that part, right? Okay, so it's 9 times whatever this is. So we got to figure out whatever this is. Well, let's just take 24. Remember how we went off to the side here? Okay, and let's break down 24. Let's see if we can make it so we can get a cube root of one of the numbers. So what times what's 24? You got a couple things. You got 2 times 12. You got what? 6 times 4. You also got something else. What else do you have? 8 and 3, right? So 8 times 3. So which one of those right off the top of your head is the one that you want to use, do you think? The 8 and the 3. Why 8 and 3? Because I can take the cube root of 8. Does that make sense? So you could just do that in your head. You could look at it and say, oh, that's 8 times 3. The cube root of 8 is what? 2. And then you have a 3 left over, so it's the cube root of 3. You could just do that in your head. You should be able to. All right? But if you can't, we're just going to do this. Let's say that you didn't even know it was 8 times 3. Let's say the first thing that popped in your head was 2 times 12. Okay? So let's break down 12. That 2 stays there. What is that? That's 2 times 6, isn't it? Let's keep that down. Let's keep that. And let's break this down. And what's that? That's 2 times 3. So if you got a number that you can't just do in your head, this is probably the process that you want to go through. All right, so what do we do once we get them all to their primes? We group them into 3s. Why 3s? Because it's the cube root. What if they asked for the 4th root? We would try to group it into 4s, right? This one doesn't do it, but we would try to group it into 4s. If it was 5th root, we'd try to group the prime numbers into groups of 5. But this one is a cube root, so we try to group it into a group of 3. So basically, that's just 2 cubed, isn't it? Okay, or 8 times 3. You with me on that? I'm going to write every little step. You don't have to do all this. Again, you could have gone right from here to what the simplified version was in your head if you're getting the hang of these things. All right? Remember, this is the cube root, so let's break it down into 2 cubed and then cube root of 3. There we go. We'll deal with this in a second. I'm just trying to simplify this one first. All right, so what's this going to be? Let's do a little bit in our head here. Okay, we don't have to write down every little step. So what's the cube root of 2 cubed? It's just what? 2 times this 9 is 18. Everybody see how we got that 18? Because this becomes a 2, and I multiply it by 9, and I get 18. And then you're just going to write the cube root of 3 right here. Any questions on what we've done so far? Now it's time to ask. All right, let's do this one. This is just the cube root of 81. Well, let's come over here again and do 81 and break that down. So you could go 9 times 9, right? So what's 9 times 9? What's 9? It's 3 times 3 and another 3 times 3. How are we going to group them? We're going to group them in a group of 3. So really, what is that? That's 3 cubed, right, times 3. We want that 3 cubed because I want to take the cube root of 3 cubed. Make sense? So I'll put the cube right here. Tell you what, let's do this. Oops. I controlled Z too many times. Let's see, what do we do? The cube root of 3 cubed times the cube root of 3. All right, what's this? We should be able to do that pretty easy. The cube root of 3 cubed. The cube root and the cube cancel each other out, so what are you left with? Just a 3. I'm going to drop this all the way down to here because I'm ready to get some like terms here. You can't do anything with that, so you just keep it the cube root of 3. So that wasn't too bad, right? All right. Again, if you don't know 81, now we just did 81 in the last problem. 27 times 3, the cube root of 27 is 3, right? So if you know 81 is 27 times 3, then you're good to go just doing that, just putting that step in your head. But if you don't, which is fine, not everybody knows 27 times 3 off the top of their head, just break it down like this and do it this way. All right, we're almost done. It's been pretty easy so far. So I got 18 of these things minus 3 of these things. They're like terms, aren't they? It's like 18x minus 3x. It's basically like that. So what would 18x minus 3x be? It would be what? 15x, right? It's not an x, though, is it? What is it? What's our like term? Just the cube root of 3. That's right. And that would be your answer. We good? Any questions? No? All right. I'll believe you. Mac, what's the next one? 42. Let's change colors. Let's go to this nice blue. 42. All right. 8xy minus square root 25 x squared y squared plus the cube root of 8x cubed y cubed. This looks a little weird because this doesn't have a square root or any kind of root. This has a square root. This has a cube root. So how in the world are we supposed to add those up? Well, let's just simplify each one of these terms, and then you're going to see, again, they rig these things so it comes out nice and easy for us. All right, so I can't do anything with that, so I'm just going to leave it 8xy minus. Tell you what, instead of writing down every little baby step, let's just do this in our head. Do you think you can? Sure. Square root of 25 is 5. Square root of x squared is x squared, and the square root of y squared is y. See how easy that is? Just writing it down. So I'm just taking the square root of everything that's inside of there. We're basically going to do the same thing with this. We've already talked about this once today. The cube root of 8. The cube root of 8 is 2. And then the cube root of x cubed is x, because the cube root and the cube cancel each other out. And then the cube root of y cubed is y. Wow, look how nice that looks. So that's pretty easy. They're all the same terms, aren't they? They're both xy's, or all three of them, I should say, are xy's. So basically, I'm just going 8 minus 5 is 3, plus 2 is 5. So it's just 5, what? xy. Easy as that. Man, these are easier than I thought, aren't they? Do you think that or not? Am I just saying that because I'm the math teacher? No, I think they are. I think they're not so bad. Just got to learn some basic rules. Once you learn the basic rules, you're good to go. 64. 64. All right, next page. 64, 27 over 8 to the 2/3 power. All right, this is a little different than what we've been doing so far. So what I want to do is I want to rewrite this. All right, we have a rule that says we can do this. Do I have to flip this fraction at all? Remember the other day? Was it yesterday, I think? We did one where you had to flip the fraction. Do we have to flip this fraction on this one? Why not, Josh? Yeah, there's no negative exponent, okay? If it's just a positive exponent, you don't have to worry about flipping this fraction, all right? So we're just going to keep that the same, 27 over 8. And now we want to rewrite this. We want to, again, they rigged this thing because I want to write this as 1 over the denominator. So instead of 2 over 3, I'm going to write it 1 over 3. But this and this aren't the same thing, right? So what do I have to do to that? Take this and do what to it? square it. Now, is this the same as this? I got an equal sign. They should be. Sure it is, because what's the rule when you have a power to another power? You multiply the powers together, all right? And 1/3 times 2 is 2/3. So is it the same? Yes, it is, okay? So now what we can do, the reason we did this is because, again, the author of the book wrote this problem so it works out nice and easy for us. So what you're doing is you're taking this to the 1/3 power. You're like, well, Mr. Hamrick, that's still not very easy because I have no idea how you take something to the 1/3 power. But do you remember what our little rule was? Anything to the, let's start with this one. Anything to the 1/2 power is the same thing as, Mac, what is it? It's just that, yeah, you could put a 2 here, but it's a square root, so you don't really need the 2. All right? Do you remember that? So what if I had something to the 1/3 power? What's that? It's the cube root of x. You with me? I could do some weird power. I could go like x to the 1/17th power. What would that be? It'd be the 17th root of x. Yeah? So let's take a look at this. I'll tell you what, since I wrote over here, let's pull this down here. So I've got everything in this fraction to the 1/3 power. Again, you should be at the point where you should be able to just do this in your head, 27 to the 1/3. So what does that mean, 27 to the 1/3 power? It means the cube root of 27. What's the cube root of 27? It's 3. All right. Let's do this, though. Let's just do an intermediate step just so that you understand what's going on. So 27 to the 1/3 is the same as the cube root of 27. Do you agree? I could have done another intermediate step. Whoops. And I could have put 27 to the 1/3 here and then 8 to the 1/3 there. All right. I'm showing you like every possible step that you could actually do. But you don't have to do all this stuff. You could do a lot of this stuff in your head. And I know I always harp about showing your work, but sometimes you don't have to show like every single step. Just show the ones that are important. So anyway, that's the cube root of 27, and this would be the cube root of 8. But we already know what that is. The cube root of 27 is 3. The cube root of 8 is 2. Now, is my answer 3/2? Do I just leave it like that? No, because what am I doing? I got to square all this stuff. So this thing right here has to be squared. You understand that, right? Because of that 2/3. And now it's super easy. We can get our answer now. Again, you could do a little intermediate step if you wanted to. You could go 3 squared over 2 squared, but do you really need to do that? I don't think so. So you got 3 squared, which is 9/4. Leave it just like that. There's no reason to change that to a mixed number, right? Kids coming out of middle school always want to change an improper fraction to a mixed number because they teach that all the time. And sometimes that's fine. Sometimes it's okay. But you don't have to. When you get into upper math, they are fine with you leaving it as a improper fraction. As long as it's reduced, though, okay? Nothing goes into that, right? 4, 9, so that's my answer. Let's do one where we have a negative exponent. One we did, something like we did yesterday. Are there any on there? Any even ones? Yeah, let's do 66. Let's go green. How's that? Can you read that one all right? Okay, 66. So it's, same numbers, except, well, it's kind of the same. And it's to the negative 2/3. That's why I wanted to do one with a negative. So this is a little bit different because you got that negative right there. We did this yesterday. What does that negative tell you to do with this fraction right here? A negative exponent always means you flip it, right? So once we have a negative exponent, what we're going to do is we're going to change it to a positive exponent, but we have to do something first. We have to take this fraction and flip it. So we have a rule that says we can do that. So let's do that. So I got 27/8. Now, instead of to the negative 2/3, by flipping this fraction, I can just write to the 2/3. It's the same exact thing. This and this are the same. That's why I put an equals in between. That's really the only thing different on this problem than what we just finished doing. Then the rest I should be able to do pretty easy. I think this step is important right here. We just did this, but I'll do it again. To the 1/3, right? And then that's squared. 27 to the 1/3 is the cube root of 27, which is 3. It's the same problem, right, that we just finished doing. Cube root of 8 is 2. We got to square it. Same answer and everything. Okay? But it started off a little different, didn't it? It started off with 8 over 27. The problem we did earlier was 27 over 8 and a positive exponent. We good?